why to use Python is it's easy and everybody's using it. What he's missing here, and that's what he's not saying, apps that run on your phone, they might use SQLite because it's basically just a file on disk. Dangerous. This is not the use case what you would do with Airflow. Hey guys, today we're looking at a video how I would learn data engineering if I could start over. It's a super interesting topic for me, especially as somebody who's doing education in this sector, and most likely also you. So let's react to this. The link to the original video you're going to find below in the description. All right, let's go.
Data is the new goal in the 21st century. Some of the big
I hate this phrase, data is the new gold, data is the new oil. People were coming up with this 10 years ago, and I feel like a lot of people have not understood what is behind or what is needed to actually mine this gold, what is actually able to or necessary to use this data. So,
biggest companies in the world are processing terabytes of information each day.
True.
On LinkedIn, you'll see thousands of job postings for data engineers, and the average salary on Indeed is $130,000.
Well, that always depends on where you are, right? So it always depends on if you're in Germany, for instance, or in the EU, it's lower. In the US, of course, it's very high. And the amount of actual jobs, yes, it's high, but also the competition right now is crazy when you look at how many people apply to jobs. Wow. I mean, last time I looked in a live stream, one job, 1,800 applicants. Crazy.
It's one of the highest demand skills in America with a relatively niche market. In this video, I'm going to walk you through a step-by-step approach on how I would relearn data engineering if I had to start over.
Well, let's quickly look at this here. So fundamentals, SQL, Python, command lines, yeah, core data, object stores, databases, advanced data, batch and stream processing. Okay, well, okay, that seems reasonable.
In each section, I'm going to cover the why, share some useful resources, and talk about the mindset in order for you to succeed. My name is Jay. I'm a full-time data engineer based in New York City, and I'm also a part-time filmmaker. I graduated from Columbia with a master's in data science in 2021 and have been really studying this field for the past 8 years.
It's interesting to see already, he actually studied data science, not some engineering or computer science topic, data science. That's how a lot of people right now get into data engineering. They started as a data scientist and they actually found out, well, science is actually the thing that I want to do. I need to look into how can I bring actually the data up to the part where I can do data science. And right now, actually, this is something that is necessary. Companies are going away from this. You're the data scientist, you're only doing the analytics part. You very often have to do also the engineering side.
If you subscribe because of my travel content, stay tuned because there's so much more to come. This video is geared towards helping people navigate their career in data. Let's dive right in. So when I was first starting out, I felt super overwhelmed because I kept seeing a lot of buzzwords on the internet.
That's true. That's one of the things you will get overwhelmed really quickly. That's also why I, back in the day, started the Academy, right? Because people are coming to me and they have heard 1,000 tools. They have heard from 1,000 people how they need this and this and this and this and this. And where to learn it, that's often problematic. So yeah, too many tools available. This is already one of the big things here.
For example, what is Spark, Hadoop, Hive? Not only that, but data engineering is a lot more ambiguous compared to traditional tech roles like software engineering. Let's take a look at an example job description on LinkedIn.
A big part actually for a lot of data engineers is actually software development. So if you're coming from software development and you have a bit of knowledge in a computer science background.
All right, let's search data engineer and, oh, this one looks good. Senior data engineer, Nike. Okay, if I scroll down to the job description.
Hey, have you seen this here?
Oh, this one looks good.
98 to 129,000. Nice, nice.
data engineer,
Also remember this is a senior role.
Nike. Okay, if I scroll down to the job description, you'll see words like expertise with relational SQL, expertise with...
Also, by the way, this is a senior role, right? So for a normal data engineer, you don't need to have everything there. And especially beginners don't need to have everything. So now let's see how much this fits to a role of somebody who wants to start over, who wants to learn.
Python, experience with workflow scheduling tools like Airflow. When you're starting out, learn about Python, SQL, and command lines. All your tools as a data engineer are going to have abstraction layers over these three things. Not only that, but you'll be interviewing using Python and SQL. So most people know SQL as a...
That's actually a good point. A lot of interviews actually focus on Python and SQL. I call it SQL first because it's easy to test. And it's a very tried and true method to test because people have been doing it for years. So is this the best way of doing it? But it's very well used, or it can be used very well for automated testing.
A declarative language used to store and query structured data. But what most people don't know is that SQL has a lot of attractive transactional properties that make it really fast and easy to use. SQL is super underrated, and it's one of the most common interfaces for databases and data lakes.
I would not say that it's underrated. I think it's sometimes people overrate this, that actually everybody needs to have a lot of SQL knowledge and to super deep down. And this is something that we use all the time. You need to have a knowledge, you need to have the basics down, you need to be able to query data and analyze data a bit there. You need to be able to interact with databases. So it's not a big deal. Super underrated. It's not super underrated. Everybody knows that you need SQL.
As a data engineer, you'll need to know about these advanced SQL topics, such as group by functions. Let's say I'm given a table of every single YouTube video in the world, and I want to find out what is the most viewed video per channel ID or the channel name. I can do that using group by functions by using channel ID as my group by key.
I don't know if I would call group by already as an advanced function. I was thinking like the window functions topics. But is group by already there? Yeah.
And taking the aggregate maximum value of views. Window functions are very similar to group by functions in the sense that they both aggregate values. They are a must-have for interviews. I remember when I was applying for all these data engineering positions, I would constantly get thrown questions about window functions. For programming languages...
It's actually funny because today I published the first part of our SQL for Data Engineers course. So it's funny to have this in here.
I wouldn't recommend starting out using Java or other object-oriented languages because the objective is to learn about data concepts, not computer science. Python is an open source language with a bunch of third-party libraries everywhere. We have some...
Now, if you're coming from Java, it's a good tool. It's a good way of coding. But I would say here the main focus why to use Python is it's easy and everybody's using it. And it has tools, and here is coming to it here. It already has pandas in there. Pandas, because with pandas it's super easy to read data, to transform data, to process data, and then to write data somewhere. There are so many pre-built libraries that use data frames, and this is one of the core things.
Something called virtual environments.
Also, scientists use pandas a lot. So this is very well connected.
Which allow us to store snapshots of your system at a point of time. And this is really key for reproducibility, where we want to build data engineering systems that are isolated against each other. For command lines, let's say we're building a data pipeline that move around files, search through logs. Command lines help facilitate that interaction and help data engineers be more productive.
Command line, I don't think so. it's getting further away from what we do as data engineers. Yes, of course, if you're on a Linux machine and you want to schedule a Python job with cron, then yes, it makes sense. But nowadays, when I think of data engineering, what are we doing very often? Where are we working very often? We're working on the cloud. We're working with serverless functions. We're working with creating Docker images and then hosting the code as containers. So the actual command line stuff, that is going away. This is the natural thing whenever you are working with the cloud. And so I don't think it's that important anymore, or it's getting lower of importance.
Here are some useful resources. I will give myself 3 months plus, and don't rush it. Take more time if you need to. The mindset here is that you should find one content that you resonate with the most and just stick to it. I've listed down a bunch of suggested materials. These are by no means definitive, and I'm also going to share a link below so you don't have to worry about taking notes. I've tried every single material out here that I'm suggesting. The ones in green are some of my personal favorites. For example, this Python O'Reilly textbook on machine learning is not really a Python textbook, but I feel like it teaches Python really, really well.
Okay, I'm not sure about that. Like, would you be better off if you have a real beginner Python book? Most likely. I don't know how much previous knowledge he has. I'm guessing he studied data science, so he already had a bit of knowledge. Yeah. Lead code for SQL. Yeah. I think, especially with Python, there are so many resources out there where you can learn Python. And the funny thing is, I actually talked with with 2 students this week that I have in the coaching, and they are just starting out with Python. And I was actually looking for resources for them. Of course, I have stuff in my data engineering academy, but there are a ton of sources out there. Like, he had also Code Academy here. You can also go to Code Academy and do a Python course, right? So it's not super difficult.
LeetCode Premium was a great resource, although I had to pay for it. There's this website called learnenough.com, and LearnEnough has a bunch of great tutorials. Code Academy is great for getting a high-level introduction for SQL. Whenever you get stuck, Stack Overflow is your best bet.
True.
Understanding data structures in Python is also one really great way to get better at learning the Python programming language.
But the thing is, people always tell me this, or you see this all the time. Data structures, you need to learn data structures. Yeah, but it's not a big deal. I mean, don't make a bigger deal out of it than it is.
Once you get really good at Python, SQL, and command lines, it's time to learn about data storages and orchestration. Data storage underpins almost every aspect of data engineering. Whether you're trying to perform ingestion, transformation, or queries, the 2 most important storage types are object stores and relational databases. Object stores.
For data engineers, yes and no. I mean, relational databases are the thing that you have all the time, but also analytical data stores, stuff like where people build their data warehouse on top of. Snowflake, Redshift, BigQuery, these are the tools that you have there all the time. So think about these as well. Just object store where you drop your files into a data lake and be done with it. Yes, of course. Now, as you said here, relational databases, that's one of the core things. You need to understand how to do a relational, or how to model a relational database, how to access with SQL your database, and how to get data and join tables and so on. But yeah, I would put in there analytic stores as well. Some would say data warehouses, but data warehouse is actually the thing that you build on top of an analytical data store.
Stores are ideal for unstructured data, such as images, audio, or text. They're inherently key value stores. Let's say we're storing a CSV file in Amazon S3. Our bucket name is like and subscribe. Our key is json.csv. Whenever we store JSON.csv in this bucket, we're also storing a bunch of useful information like the versioning, the metadata, data about the data, or backups in case something goes wrong. And that's what really makes the engineering side of things. For relational databases, I want to emphasize...
Like, I don't agree here fully. Yes, the name of the file is the key, but depending on the amount of files you write and the actual thing that you do with it, the key might not mean anything. And calling this key value store is very, very dangerous, because there are actual key value stores out there where you're storing a key and that key is indexed, and then you have values into them. So, or connected with them. So, yeah, but as I said, like these object stores, they are important, but I don't think to call them key value stores doesn't make sense here.
Emphasize that it's oftentimes the solution to most data engineering problems. The most widely deployed database in the world is not MySQL, it's not Postgres. Surprise, surprise, it's actually SQLite. And that's because SQLite has extremely fast lookup times. When you talk about data organization,
it's also very lightweight. And what he's missing here, and that's what he's not saying, SQLite actually is deployed on many devices. So it's not just in a server environment. On your phone, when you have your phone, apps that run on your phone, they might use SQLite because it's basically just a file on disk that you access and use as a relational database. So that is something you need to keep in mind here.
Orchestration, it's usually related to data warehousing. The process of getting data into a warehouse is called extract, transform, load, or ETL for short. You're going to see this term a lot in your career. Why do we need data orchestration?
ETL is not just for writing data in the data warehouse. It's basically whenever you extract data and write it somewhere. That's basically an ETL job. You extract it from an API, you extract it from a relational database. You transform it to store it somewhere. In a data warehouse, in a relational database, in an object store, whatever.
Let's say we're scheduling jobs at a specific cadence for a bunch of useful tasks. It could be a daily job in the morning that ingests data into your warehouse. The second thing is that we need data provenance, essentially asking the question of where did the data originate from? Directed acyclic graphs, or DAGs, help us organize workflows more programmatically. Apache Airflow is the gold standard. I personally really like Airflow because it has great logging capabilities and it has a very sleek user interface to visualize how your DAGs look like. Here are some resources to get started. Focus on...
I mean, Airflow is not everybody needs Airflow. There are many tools to actually orchestrate your pipelines, to schedule your pipelines. And scheduling is only a small part of the pipeline orchestration. But like every cloud platform has their own scheduling, has their own orchestration tool. And just saying Airflow, it doesn't make sense. And if you're back when you think about back in the days, you had a Linux machine, a Linux server, you wanted to run code there. What would you do? You would create a simple cron job, and that cron job starts at 1 in the morning and makes a backup or something. So, yeah. So be careful to when everybody tells you you need Airflow for everything. That's not true.
Learning concepts and building projects. When we learn how to code, we don't read books to learn how to code. We learn through trial and error and making a bunch of mistakes. I personally would just skim through the documentation of whatever tool that you're interested in learning and immediately jump on a project. A fun project idea that you can try is to create an Airflow DAG that extracts data from your favorite source and uploads it to a data warehouse. I think this is a great...
Dangerous. This is not the use case what you would do with Airflow. Airflow is not there for processing, for extracting data and writing it somewhere. Airflow is for orchestration. It will orchestrate a job that runs somewhere that actually does this, or multiple jobs. So I say this because I also teach Airflow in my academy with that kind of concept, to extract data from somewhere and process it and write it somewhere. But within Airflow, especially for larger amounts of data, that is not how you use Airflow. Be careful.
Great project to have because it combines your passion and data engineering to create something that you can showcase to other people.
That's actually super important. I think that is one of the big things, creating a project and using these resources just for a lookup whenever you have problems, whenever you have questions, whenever you don't know something. And do projects. That's also what I do with a lot of my students. Okay, now I'm excited.
Let's talk about advanced data skills, which are batch and stream processing. This is
Okay.
what differentiates traditional software engineers with data engineers. With batch processing, it's often related to big data tools such as Apache Spark. The core
Yes and no. So Spark, yes, you can run batch and stream processing with Spark, but basically any process where you schedule this process and this runs on a schedule, that is basically a batch process. Right? Spark is just a tool that we use because it's very scalable and very powerful.
idea is we have data that is growing at unmanageable sizes. In order for us to make sense of them, we built these tools to process them in a scalable way. MapReduce is a distributed framework within the Hadoop ecosystem where we have a map function that splits data between parallel tasks and a reduce function that aggregates the data. Whenever you see the word MapReduce, I want you to think that the order does not matter.
Well, MapReduce is something, the whole concept still applies, but basically you never see it anymore. MapReduce is basically over. That is it from the Hadoop days. Nobody's using Hadoop anymore, or almost nobody. Almost nobody's using MapReduce anymore because MapReduce was annoying. You had only map and reduce stage, and then you needed to write to disk. Nowadays with Spark, the concept deep down is still there, where you map data and then basically reduce it or process it and then do another map, for instance. But like nowadays, it's not that important anymore.
I don't actually suggest learning a specific tool apart from Apache Spark. Instead, I would focus on understanding concepts and create a project using a tool that fits your needs. One misconception is you need to be an expert in these big data tools, which is totally wrong. You'll likely learn these on the job, and not only that, these tools are constantly evolving. For stream processing, let's say we're trying to build a real-time application where multiple sources are feeding into one system. We have something called a publish and subscribe model. Apache Kafka is one of the most popular frameworks because it has high throughput, it's scalable, and it maintains a commit log that is immutable. One real-world example is how Netflix uses Kafka.
The thing is, I'm not sure, I don't see it here anywhere. Right? Kafka is a streaming or a message queue, but the actual, only a part of a streaming pipeline, right? You need some processing. That is one of the important things. Spark can do that, but there are also other frameworks like Flink who are super good at stream processing. So Kafka is just a part of it, just especially as a message queue, super important. Now let's see what he says.
For all your messaging and streaming needs, there are billions of data points processed using Kafka each day, and that's how important stream processing tools are. Here are some resources.
But there are also other tools. Not everybody needs a Kafka message queue. Not everybody needs a scalable message queue with multiple brokers where multiple devices can read out of it at once and so on. There are very simple message queues, like for instance on AWS with SNS, SQS, that work in, let's say, 50% of the time or more. People use these because they don't actually need Kafka, or in AWS is Kinesis, because it's putting a big overhead on top of it and it's also expensive.
Sources. I want to caveat this by saying batch and streaming tools are constantly evolving. By the time you master one tool, it's going to be obsolete very soon. I would actually...
Not really. Not really. Kafka is there forever and people still use it. With the cloud platforms, what do they have? AWS has Kinesis, Azure has Event Hub, and GCP has PubSub. These things are there forever. Like they are not going to go away.
Focus on learning the concepts instead, and just work on a project that you can showcase to your friends or your interviewers. I feel like this MapReduce paper is a must read for all data engineers. This class Introduction
Show
to
it, come on.
Distributed Systems. The first lecture gives a great umbrella overview. Try to pick up some of the high-level gems in this video. Here's a practical project idea. Implement word count using MapReduce.
Dude, that word count thing. People like, don't do this. Don't do this. This word count is super boring. Yes, you're going to understand it, but you can also read about this. You don't need to implement this. This is like, nobody does this anymore. Nobody's using Hadoop anymore. Nobody's using MapReduce anymore. You can do this with Spark in a very simple environment. So do that.
Let's say I'm trying to count the number of words in a book. It doesn't matter if I count from the first page or the last page. The outcome will still be the same. This book is 10,000 pages long, and I have 10 computers counting at 10 pages each. This will help you understand what MapReduce is. And like I said, the order does not matter. What I didn't talk about in this video are specific technologies like Snowflake, NoSQL, Redshift, Tableau, BigQuery. These are all amazing tools with a bunch of resources on YouTube, but you don't really need to learn these tools unless your job requires it. Remember that these are tools only, and data engineers use tools to solve problems, not the other way around. If something basic like...
True, but I think at least one analytical data store you need to use, right? So Snowflake, BigQuery, Redshift, Synapse, whatever. I think one of DuckDB, like one of these things you should do.
Like SQL is the answer, then stick to it.
Yeah.
Now let's talk about the mindset in order for you to succeed. Practice through project work and focus on building a portfolio. That is the best way to get better. The hardest part of starting out is feeling lost because of the sheer number of resources available out there. One quick remedy is to stick to one material that you resonate with the most. Finally, learning about data engineering is going to be a lot of hard work, and it can be late nights, but it's also one of the most rewarding and fun career paths that you can have, in my opinion. I hope you got something out of this video. Everyone's journey in starting out is going to be a little bit different. Comment below what's your journey like and how you learn best. If you enjoyed this video, like, subscribe, and thanks for watching.
Yeah, I mean, I'm not, like, I was hoping that he talks more about his journey and what he would do different. So I don't know. I would love to hear more about his experience. What was here at the end?
Finally,
yeah, basically also focus on one thing and do that, and use practical examples. That's the basis how I basically built my data engineering academy, right? We have over 30 courses built here that where most of the things I've done. And this is always based on some practical examples, some practical things, practical projects that you do, because these you can put into your GitHub, create a portfolio, and then show this to people whenever you apply to a job, right? And go step by step. I think that is a very good example. Yeah, so generally I like the video. He had a few really good points, but I was hoping he would talk more about, this is what I have done, and this is what I would have done different, instead of just teaching us again what are the basics. Yeah, that's how it is. So the original video is linked below. Go there, leave a like. I'm also going to go here. I'm going to leave a like here. And yeah, see you in the next video. If you have a cool video, let me know over Twitter what you want me to watch and react to. Bye.